Welcome to all. This is lecture number 38 of part 1. We are just one or two class away from closing the part 1. Now, last class I told about concept of couple. I clearly told, see, two equal unlike parallel forces with the different lines of action will form a couple. Yes, everybody will understand. But so many times I got questions from people. If you remember, long back we solved a question. See, not same question. A coplanar force system is given. You have to find the resultant. What I told you is resultant can be either in the form of a force or it can be in the form of a couple. But usually it will be in the form of a force. So first find, see, this all you are right. Sigma fx and sigma fy. If both are present or even if any one of them is present, resultant is in the form of a force. So find the resultant force, magnitude, direction and line of action all over. But if everything you are right, remember, if sigma fx and sigma fy both are 0, then I told in the class, in a hurry, never come to conclusion drastically. Oh, no resultant. No, not that way. If resultant force vanishes, the system can reduce to a couple or the resultant can be in the form of a couple. See, now you know it. See, if you apply two equal unlike parallel forces, resultant force 0, but you know that there is a couple. Therefore, there is a couple. You also know one more thing. Moment of a couple about any point in the plane is constant and same. That is, whichever point you consider moment, answer is same if resultant is or if the system reduces to a couple. This all already told earlier. Now, see, basically, when couple comes, what comes to mind? Two equal unlike parallel forces, correct. But now, for this system, I set the question so that this will have no resultant force. The resultant is in the form of a couple. Somebody will ask the question, sir, there are so many forces, 1, 2, 3, 4, 5, 6, 7, 8 forces, and equal, unlike, all are mixed together. It is not a parallel force system. Then how you can tell there is a couple? So, today's class is an concept-based class or meant for sharpening your structural knowledge. Remember, this class, if you go through thoroughly, will help you to understand a lot of things. See, structural engineering is not just a calculation part. There is thinking and, of course, understanding. 1 minute, I will explain to you, one by one, systematically. Start. Question dictated in the class. See, question. For the given force system, find the resultant completely. Someone will tell, it is already over. No, for some reason I am doing it. Okay, that is the question. Start. Forces are given here. Too much statement I am not writing here. See, on the board I already wrote because what is on the board is already over earlier many times. So, the second part, that is the concept, will come second part. See, sigma fx, right side positive. Start here. Where is 65? Minus 65 plus 35 plus 45 minus 15, 0. Oh, sigma fx 0. Sigma fy, upward positive. Minus 60 plus 30 plus 70 minus 40, that also 0. Now see, this statement I told many times, but as a revision I am telling once again. Since both sigma fx and sigma fy are zeros, there is no resultant force for given force system. Resultant in the form of a force does not exist. As already explained many times earlier, that is, just because resultant force is 0, in a hurry we cannot come to the conclusion that there is no resultant. I told you, because it is possible that the resultant can be in the form of a couple. Okay, now, class, I am dictating. How to find it? Of course, right, by chance, if resultant couple is also 0, then there is no resultant, system is in equilibrium. Okay. Now, further right here. Let us check whether the resultant exists in the form of a couple, for which let us find algebraic sum of moments of a given force system about any point. Now, class, if the resultant is in the form of a couple, means the system reduces to a couple, then you already know moment of a couple about any point in the plane is constant. Someone will still tell, sir, only two forces you are telling. Wait for some time. Don't be in a hurry. What I am telling, listen. Sometimes it happens. They will tell, sir, couple you told only two forces. I am coming to it. Two equal, unlike parallel forces. Wait. Okay. Members of the given force system class. Now, about any point. Now see, class. We can take any point. My guarantee, or why my guarantee, is a true universal truth. If the resultant, you should write all these things if you want. If resultant is in the form of a couple, then that resultant couple is, you should write algebraic sum of moments of the entire given force system about any point. Whichever point to consider, answer will be same. Okay, let us take about A. Start. Waves, because already told, algebraic sum of moments of the given force system about A, moment in Newton meter, we will take what? Clockwise positive, some sign required, clockwise positive. Start. Moment about A. Put finger here. 65 into 0. Okay, then 35 into this distance. 2.5 minus 0.8 is 1.7. I wrote it there. 60 into 0. 30 into 1.6, anti-clockwise, minus 45 into 3, not 3, sorry, 2.5. I wrote 2.5, clockwise. 15 into 0.6, anti-clockwise. 70 into 3, anti-clockwise. 40 into 1.8, why? 3 minus 1.2, clockwise. When you calculate, it is coming minus 23 Newton meter. Okay, now, do one thing. Class, you take moment about any point, answer is minus 23. 1 minute now. I will take A, I did it. I will take about C, I will take. See now. If I take about C, start from here. I won't write in the board. 45 into 0. 15 into 1.9. Clockwise. By 2.5 minus 0.6. Clockwise. 70 into 0. 40 into 1.2. Anti-clockwise, minus 65 into 2.5, clockwise, minus, so anti-clockwise, 75 into 0.8, 60 into 3, anti-clockwise, minus 30 into 1.4, clockwise, plus, you calculate, I am calculating, minus 23 Newton meter. Or, do one thing, take moment about B point, this you try, minus 23, or take moment about D point, minus 23, or take moment about E, minus 23, take moment about F, I am calculating, minus 23, take moment about G, minus 23, take moment about H, minus 23. Take moment about any random point you mark. At whatever distance you want here, you write whatever you want here. Take moment about that point. Minus 23. Mark your outside random point, wherever you want. Thousands of kilometers outside if you want. Take moment. Minus 23. Sufficient. Leave it. This is called confidence. Not, okay, minus 23. Right. Now one note. When you calculate algebraic sum of moment about any point, if the result comes, or if you get a value of a couple moment, then that itself is the resultant in the form of a couple. Therefore, I will close down by putting a statement here. See, I write here. Therefore, conclusion. Therefore, red color I want. See, red color, red color. After everything is over, come this side, right? Therefore, resultant for given force system is in the form of a couple, or you can do one thing in the form of, see, we took clockwise positive, negative came, or you can write in the form of an anti-clockwise couple, to make more clear, or either anti-clockwise or counter-clockwise. Suppose you got a plus, write clockwise. Anti-clockwise couple of, no minus now, 23 Newton meter is the answer we got. Now write a note. Red color I am telling, note. This he already did. This was already over earlier. Actually, some will tell, sir, you are extending the class for no reason. This already over. Yes, already over. Now, what is coming up now is real concept. See, once if you really go through this question thoroughly, what all I am showing calculation here, if you understand correctly, you will start getting fascination for structures. This will give you fascination for structures. So now I am removing everything here. My guarantee, again you get the couple. But this time we will get the couple. See. But remember, I am guaranteeing it is 23 Newton meter anti-clockwise, my guarantee. I will remove and write some statement now. Okay. Start now. This is the real concept. From now class starts. See, what to do is class. People who are asking, sir, for couple we require two equal unlike parallel forces, sir, but there are so many forces here. Sir, how you tell it's a couple, sir? See, confusion. Wait 1 minute now. See, what I am doing is, see correctly. What all I am telling, you have to write if you want to understand. See, there is a 60 Newton force down and also one more 40 Newton force down. 60 Newton down is at D and 40 down is at H. See correctly, 60 Newton at D, 40 at H. Consider 60 Newton down at D and 40 Newton down at H. Okay, only those two forces, nothing else. Find resultant and locate line of action. Right, start. I think nobody requires any hint here. Let R be the resultant for these two forces. 100% R equal to 60 plus 40, 100 directly. If this is not clear, better drop the subject. Okay, now right here, let the resultant be at X from here. To get X, apply Varigno's theorem. Take moment about any point in this line of action. See here, 60 into 0, 40 into, you should write it, if you want write, algebraic sum of moment of the force system is two forces. About any point equal to moment of resultant about the same point, any point here. Start. 60 into 0 plus 40 into 1.8. How we got 1.8? See correctly. 60 here, 40 here. So this is 60. Don't see this one. This is 3. This is 1.2. From 3 subtract 1.2, 1.8. So 60 into 0, 40 into 1.8 equal to resultant R into X. Clockwise, all are clockwise. Positive. Your X will come 0.72 meter. So for this 60 Newton force and this 40 Newton force, both of them are downward. The resultant force is 100 Newton down from 60 Newton acting at 0.72, or if you want from 40 Newton, it is how much? From 1.8, subtract it, you get 1.08. Rounded means calculated, right here. How I got it? From 1.8 subtract. Okay, right. Now consider 30 Newton force at F and 70 Newton force at B. Okay, both are upwards. See, both are upwards. Repeat the procedure. let the resultant equal to R. This R is not that R. R, 100 once again. Yes, to locate, take moment about this point. If you take clockwise positive, 30 into 0 minus 70 into 1.4 equal to minus 100 into x. X will come 0.98 meter. So, for these two forces, means for this force and this force, the single resultant force is 100 Newton up, acting at 0.42 meter, so 0.98 meter from 30 Newton or 0.42 meter from there. Okay. Now see correctly what happens. Therefore, see, now I'll write a sketch here now. I want to, okay, I'll write, I should make a note here because space problem is there. I want to write a sketch. This, see, this I should have written somewhere. Okay, I write here now. Therefore, see, not now, little later you are right. Therefore, one thing, no ABCD. There is a, see, there is a downward force of 100 Newton here. Yeah, see, 100 Newton here. That is resultant of these two. You can replace these two forces by 100 Newton down and these two forces by 100 Newton up. Up. I want distance between them. How much? See, this is 60 is here. From 60, x equal to 0.72 meter. Okay, then from 70, it is 70 is here. It is 0.42 meter. This distance will be, see correctly, from 3 meter, full 3 meter, subtract 0.72, also subtract 0.42. You will get from 3 subtract 0.72 minus 0.42 comes to 1.86 meter. 86 meter. Now see here, oh, right here. This is, see, right, some statement I am giving. Oh, this is two equal unlike parallel forces with different lines of action, and this will form a couple. Moment of this couple equal to moment of this couple equal to any one of the force 100 into 1.86 equal to 186 Newton meter. See here, this way it is anti-clockwise. Okay. Now 60 Newton over, 30 Newton over, 70 Newton over, 40 Newton over. Now go for horizontal forces. See, perfect means you should have perfect concept. Little fast I will do now. Little fast I will do. You write neatly everything. Okay, this 1 over now. See. Okay, now I will remove this one now. Okay, start. Now, see what I am doing. Consider which one? See, 45 Newton right side and 35 Newton also right side. 45 Newton is at C, 35 at E. At E. Okay, start. 45 Newton here. 35 Newton comes here. Little bigger. Okay. 35 Newton here. Distance between them is very clear, 0.8 meter. 0.8 meter. Now this will have a resultant force. Take R. I think everybody can tell R equal to 45 plus 35 equal to 80 Newton. Let it be at X from here. Okay, do one thing. Take moment about this point. 45 into 0 plus, or if you want anti-clockwise positive, what 45 into 0 minus 35 into 0.8 equal to resultant R into X anti-clockwise minus R equal to 80. Therefore, your X will come, that X from here where resultant force acts. X will come 35 into 0.8 divided by 80. 0.35, 35 into 0.8 divided by 80. is 0.35 meter. X will come 0.35 meter. Okay, X will come 0.35 meter. Now, next, consider here 15 Newton left, and also this is at G point, G, and 65 Newton left, that is at where A, see, 15 Newton is this way, 15 Newton, 65 Newton is here. Distance between them is 0.6 meter, visible. Let resultant is like this, resultant R. Let it be at X from here. Okay, start. X from here. Or take from X from top only. Okay. Or 1 minute now. If that is 0.35, this will be 0.8 minus 0.35. If you want 0.45 meter. If you want it. Here. Let it be X from here. Same way, calculate X. Now you should do it. Take moment about this point. 15 into 0, 65 into 0.6. Sum of moment of the two forces equal to resultant R equal to once again 80. R is 80 only. 80 into X. X will come 65 into 0.6 divided by 80. 0.4875. It will come 0.4875 meter. If that is 0.4875 meter, this will be minus 0.6 is 0.1125 meter. 0.1125 meter. Now write, now see, you can remove this 35 Newton force and 45 Newton force. Both you can remove. In that place, you can put a single force of this one, see, a single force of 80 Newton. That is acting at what distance? Okay, then once again, this 15 Newton force and 65 Newton force you can replace by one more 80 Newton force here. 80 Newton. This distance we want. How? See, from here 0.35, from here 0.1125. So from 2.5, from there minus 0.35 minus 0.1125 is 2.0375. 2.0375 meter. How to calculate? Okay. If you want, tell me how to calculate. 2.5 minus 0.35, already calculated, minus from here 0.1125. Now right here, Udgara, here also, see, Now you got two equal unlike parallel forces with the different lines of action. This will form a couple, and moment of this couple, I told moment of this couple, okay, this couple equal to any one of the force 80 multiplied by 2.0375 equal to 80 into 2.0375 equal to 163 Newton meter. See here, see, clockwise. Okay. Now last statement closed. Therefore, conclusion now, this is all I am removing now. Now see, now you can do one thing. See, earlier I told you, you can remove this force, this force and this force, and this force, and put a couple of how much? 186 Newton meter anti-clockwise. Now you can remove these two forces and these two, everything you can remove and put a couple of 163 Newton meter clockwise. Now, therefore, for given force system, we get one anti-clockwise couple of, wherever you want to mark it, 186 Newton meter, and a clockwise couple of 163 Newton meter. Now, therefore, see, earlier I told, if you remember, when I told the characteristic of a couple, if a number of couples are acting in a plane, the resultant couple is a single couple whose magnitude is equal to algebraic sum of moments, magnitudes of all the couples. Sorry, algebraic sum of the moment of all the couples. Therefore, the one anticlockwise. Therefore, we can replace above two couples by a single couple of how much? 186 anti-clockwise plus 163 clockwise, or equal to 186 anti-clockwise, 163 clockwise means plus only or right, no minus sign. Why should I calculate? I know the answer. It is 23 Newton meter. Otherwise, my words has no value at all. Okay, 186 minus 163 is 23 Newton meter, anti-clockwise higher, that much anti-clockwise. Oh, same answer what you got. Therefore, remember, never think that for a couple you require two equal unlike parallel forces. If a multiple number of forces are there, finally it will reduce to two equal unlike parallel forces. So that's why basic definition we always tell two equal unlike parallel forces with different lines of action. If multiple forces are there, see in case of beams there are so many loads are there. Still you tell sigma m equal to 0. Why? There is no couple. Same reason. There also net upward force, net downward force, both of them will have same line of action. If line of action is different, it will not be in equilibrium. Okay, now hope the concept is fully clear. This class is meant only for those who want concept. Title I will write. For those who want to learn more and more. Something I will write. Okay, thank you. We will meet in the next class. That is almost closing class for part 1.